All right, hold on. Let me just remove a few things I have running. Okay, so are you able to hear me, and how long is the delay? Okay, so you're either gonna hear me through the video or you're gonna hear me through this website, Discord, whatever it is. So let's just keep both of them rolling, and so we can see what we have. Okay. So let me shut down my phone since I don't need it anymore. And let me switch to my desktop. Hold on. That's not what I wanted to show. This one. All right. Okay, so where do you want to start? Give me something to start with. You want me to start typing everything from the beginning so we can start our project from scratch? Or do you want to troubleshoot the issue you're having with the Pico and the NRF? Do we have a long delay or what is going on? Jesus. I'm going to hide this thing. Yeah, that's fine. So, do you want me to start? Okay. All right, let's do this. Well, you are able to hear me, right, from YouTube? All right, so let's start from the beginning then. So this is the one I was going by when I was helping you yesterday. So this is the file, right? We're gonna start right from scratch. We're still gonna make another one of this, which is the CMake. Uh, so let me move this to the side so I can have it as a reference. Make it easier on myself, and then I'll open a new one. All right, so here's my new window. and we're gonna go and create a new folder, and we'll go to YouTube. Let's create an scratch. We only hold on. Let me move your window to the other side, this window, so I can see as you type. So we only need to move this guy in there, the Pico SDK import CMake. So I'm gonna make a copy. Now I have my folder, good to go. I'll open my folder in VS Code. Did you finish opening? Yeah. Alright, so now I'll just create my CMake lists txt file. And hold on, let's see where that one went. So first thing we have to do is, obviously we have to create this. I don't know what this is called, but this is just the setup for the compilation. So CMake minimum version, and this is version 3.2, 3.12. We need to include this file here. All right, so we'll just go back that one and set the language or the compiler. So we're going to use CMake CXX for the standard, and the standard is 17. It's the one I've been using all this time. Specify a project name. This will be, I guess it can be driver. Let's just call it driver. Doesn't really matter. Initialize Pico. And we add the executables. We don't have anything yet, but we're just going to add this and keep it here. So you specify the driver, and then here you will have your executables. We don't have anything right now, so we'll leave it blank. Specify the target. Include directories. We don't have anything yet, so let's just do driver. And then the target link of the libraries driver. And right from the start, we're going to use the Pico live, and that's all we're going to use to begin with. And the last one will be the add extra outputs for driver. So this is the line that is required to create the UF2 file that goes in your Pico. Without it, it wouldn't work. So let's just create a file. So we have something to start with. Actually, before we create a file, since I'm not familiar with using what is this called? VS Code. I don't know how to. Hold on, I'm trying to size another window in my other computer. Okay. I don't know how to make it recognize this unless I just close it. So I will close the folder, and I can go back to my folder and just bring it back in again. And now it'll pick it up. You'll see all this stuff at the bottom, and you'll see it'll give me the options here. Select my GCC option, compiler. I'm not sure what that is exactly. Let's remove this since we're not going to have additional folders. We're just going to have everything there. So the first thing we want is we want to include a file, and this will be our main CPP, right? So now here on our executables, I can just say main.cpp. It should be good to go. Go back to main. We can include the Pico. And by the way, if you didn't write, you'll see this. when you did everything correctly, on the CMake list txt file, and there's the stdio. This one, not okay. We'll have a main function and our while loop, and let's see if this compiles. Okay, so it created our folder, and we should see the UF2. We should end up having a driver UF2. So there's the file. That means we had a successful compile. Obviously, you can see it at the bottom here, but we have the file to put in the Pico. So let me plug that in, so we can test it as we go, and then we can write a driver for it. Okay, we'll use this guy right here. Okay, so what I have, we are going to use this unit right here. Let me set up my camera so you can see it right there. It has an Nrf connected to the Pico, and we're going to use an HM11 to communicate with my phone. That way we can see data coming back and forth. Okay, this is going to take a little bit of coding because we're doing it from scratch, and like I said, I haven't been keeping up with this thing, so let me switch to my code window and open what we need. So we need the, what is it, this one here, so I can explain the connections. So this is how I have my wireless unit connected. So we have the MISO, or master in, master out, for 16. Actually, you're supposed to refer by this number, GP12 and 11. The clock is a GP10, and then we have the, I guess this is the cable select and chip select. So GP9 and GP8. Obviously the GP9 is for telling the unit if you're going to write or read data, and then CE is for, I'm sorry, the other way around. I don't remember. Doesn't matter. Anyways, so let's open the the data sheet for the Nrf. I gotta find that one. Let's see, where can we get it? Hold on. Data, PDF, Nrf, Alright, so this is our data for the Nrf, or what we're going to use for the driver. And we need one more. We also need the, I believe it's this one, which is the SDK. Let's see, Spi. So this is what we're going to need to connect to it. So let's just keep the reference there and go back to our coding. Okay, so let's start. So the first thing we need is for a driver, I'm going to create a class. And for the class, I will create a new file. So first, the file is going to be Nrf24h. We're going to keep both the header information and the class itself separate. So we're going to create one more, Nrf24cpp. So So this is going to handle all the code for it, and this is going to be just my class, my class definition. So we're going to use. Is this the one I created? Let's see. That's not the one. That one. So this is just a template that I had defined a while ago. So I'm going to use this, and I use this for all my classes. So we're going to leave it with that same name. And here we can have whatever is going to be public and whatever is going to be private. So the first thing we need is, obviously we need to go first see what we need to do. Let's see, is this the one with the comments? I don't have the comments on this one. Let me go open the other file. See if this one has the comments. I don't have the comments. That's fine. Let's go find it. Go look for the flow. Nope. Alright, so let me add something here, a note, just so we know that these are the register map. So we can switch back and forth, easy. Right, so when I click it, I'll go there. And then we also want the flow, so we know what to do with it. So I will add one here, and we'll just say flow. So that should be the only two we need. All right, so we can go to register map and flow, back and forth. All right, so the first thing we need to do is get a handle of the SPI, because this talks using SPI. And let's see what the communication is. Where's my SPI? There we go. Add one more note, SPI. And is that all we have? That is all we have. Okay. So, go back here. First thing we need to do here is we want to define our class, and it should be, is this mine? No. This one? There we go. Nope. That one. Hold on, I'm looking for my, I don't want to retype that whole thing, but anyways, I guess I'm gonna have to type it anyways. So I'll just put one more, Nrf24. This is just to make sure that it doesn't get defined multiple times as I start including files. And define and it. And I'll move this to the bottom. And I can start including my classes, whatever it is that I'm going to use. So I'm going to use hardware, and it's going to be spi.h And obviously this thing is not coming up because I don't have it here. So it should be hardware, SPI should be it. So now when I do this hardware, we'll figure out why it's not coming up. All right, so the class, what do we need for this class? Well, we need to keep an instance of SPI, right? And this is going to be an SPI, what's it called? Instance, and T, and we'll just call this SPI, or actually port. We also need a pointer for CSN and a pointer for CE, because those are the ones we are going to be flipping back and forth. Those would be these two guys, which is they're mainly for signal, one for signal SPI and the other one for signal in if we're going to be sending RX or TX. Okay, so here it is. So this is for SPI, CSN is for SPI, and CE, well, CSN is to select the peripheral that is connected to your unit, and CE is to switch between RX and TX. Okay, so we'll have a CSN and we'll have a CE. Okay. The what else do we need? Functions. So we're going to add some functions as well. So the next thing we need to add is, and this is not required, this is just for flipping this back and forth if you want to type the whole line all the time, or you can just make it easier on yourself and just call a function to switch it up and down. So we'll use Gpio, put this will be CE and this will be 0. We'll do the CE high, and this will be 1, 1, CSN, CSN, CSN high, and CSN low. Alright, so that should give us what we want. Where would that be? Oh, that one. There you go. Nrf. Thank you. Nrf. Nrf. Okay, we should be good. Yep. Got all of them. I think. Yes. Okay, so we're using the GPIO. We don't really need to add it here, but we are going to include it. This is the hardware again, GPIO package. And we need to add some public functions now. So first thing we need to do, let me go to the flow. Actually, let me go to register map. Let me add another node here. Commands. Sorry about that. I had to go do something really quick. So um, for this thing to work, uh, hold on, let's see. Yeah, I had to mute this thing because I was doing something else. So uh, we should be good now. Okay, let me switch again. So for this thing to work, all right, so we need to power up the unit, wait 10.3 milliseconds, so it resets. I guess it completes the entire power cycle. We have to change a bit on a register to 1, this bit, and then give it a pause of 1.5 milliseconds or 15 microseconds. And then we end up here, and then from here we can go either way, right? We should be able to go to standby, send data, or receive data, whichever of those three options we want to do. So in order to do that, these are the registers we need to change. So when it powers up, we need to do a configuration, right? And then we need to change this to 1. We're also going to leave this as 1. This enables CRC. This right here. Change my cursor so it doesn't zoom in and out. And then there's other sets of settings that we need to change. So first we need to set the SPI. So let's go do that. Actually, let's define the functions first, so then we can set the SPI. So the first one will be, we want to configure this. Well, we need to read a register, so it will be 8 bits, and we'll just say read register is read. And that would be the register. The next one will be, we want to be able to write a register, and this is not going to return anything. Write register. What do we need on this one? We need to specify the register, and we need to specify the data. One more. If you saw my previous video, you know that I have two. One for assuming that you're only writing 1 byte, and this one you specify how many. So you give it the size of the data you're going to write. So once we're able to read and write to the registers, now we can configure this information. And I guess one of the things we could do is we could have a name, so we can specify the name of the connection, and we can have a channel. Right, so now we have two things that we can specify. Next, we want to do be able to switch between transmitting and receiving, send a message, and this one's gonna have just some message or data, and we want to be able to receive a message. And we should pass a buffer so we can receive that message. We want a flag to tell us if we have a new message. And that's about it. The rest would be extra stuff that you want to have if you want to specify the name, or kind of like what it's doing here. If you want this separate, you can always set it separate, so specifies the name for receiving or transmitting. One thing we do need to do is we need to change this, because we are going to have an initialization parameters, and this will be for our port 16. This is for the CSN and the CE, and this same thing here. Gonna copy it to the constructor. So that should be the end of the header. For the driver, now we need to copy this. We cannot have the actual functions in the same file if you're going to have a separate file for the functions. So you can't have both of them. So you have to keep definition only on the H file or on the header file, and you have to move all your code into your C++ file. So we're going to remove this, or it's going to give us a bunch of errors. Paste it there. We can include the Nrf24, and that will take care of that. And also now we can copy this once. Put them there. Format them. There we go. And we'll just have to include this at the beginning of all of them. Right, so there. And I'm going to return 0 here for now, just to keep it flowing. So now, when we instantiate the class, we want to keep track of our stuff. So we want to save the port, CSN, and CE. So we'll just do the call our local variables or our member variables and assign the port. The same for CSN. We'll see why it's not coming up here in a minute. And CE. We'll go back to the class, see why that's not showing. Huh. I wonder if it's because it's private. Oh, it shouldn't matter. Something else is going on. Doesn't matter. It'll come up when we try to compile and see why those things are not showing. Okay, so is that what I named it? CE, CSN, yes. Where am I? Right here. So now we need to initialize the SPI. So we can call SPI init, and you specify the port. So we have this port already. We're going to use 1 megahertz. So 123, 123, that's 1 million. Yeah. I don't know how fast you can go on this one. I know the Nrf unit can handle, I believe it's 8 megahertz. I think can handle. Where is it? 8 megabits. Okay, whatever that means. So once we have this, we need to specify the pin connections that we're going to have and enable SPI on those pins so it starts working. So we said it was going to be on 8, 9, sorry, 10, 11, and 12. So we specify the function of those pins, and it's going to be 10, right? And it's going to be GPIO function SPI, and we'll do 11, 12. We go back here and make a change. So we have SPI. Yeah, that's all we need. Bring this over just in case. Is that where it needs to come from? Maybe not. STDIO. Hold on. Yeah, it is coming from GPIO and from hardware. Okay, doesn't matter. Let's just continue. All right, so GPIO initialize. This is incorrect as well, so it needs to know. So GPIO, and we are going to initialize CSN and CE, and then we specify the direction, just the direction. CSN will be an output, GPIO set direction CE will be output as well. And now that we have this, we can just say, okay, we need to initialize CE and CSN, how they're going to be their default state. So CE low will be low, obviously CE, and CSN will be high. And this is because, if we go back to the flow, here it says that, where is it? Let me get my, here. All right, so once you power up and you end up in standby, if you want to go send data, then you have to pulse CE to high, which means that you have to keep it low, right? It has to be low unless you're on receiving data, which you have to keep it high. And the CSN is the one that in SPI is the one you use to tell a peripheral to say, I'm communicating with you, so here's your data. So that's the one that we have to take it from high to low. So you set a specific wire that is connected to your peripheral to low, and that way it initializes communication. So in order to set it to low, it has to be high. Okay, so that's it for that one. And these are the functions we created at the beginning. You can see these are the ones. CE is low and high, and same for the other one. So let's go read some data now through SPI. And so we'll specify a resolve. This is just to hold whenever we're gonna read. So we're gonna read a register and result. And then we set CSN low, so that pin is gonna go low. Nrf is gonna know we're trying to communicate with it, and we can use SPI write. And this might be a little confusing at the beginning because you're writing data when you want to read it. Well, you have to write the register you want to read. So you're going to tell the device, this is where I want the data to come from. So we're going to write blocking. And we specify the port, which we already have, and the register. This is the register we're passing it. and we specify how many bytes, right? It's 1 byte. And now that we did this, now we can go read it. So SPI read. Wait. The reason it's not highlighting my code as I'm typing it is because I have a lot on the background. I'm streaming and recording at the same time. So I guess my computer is having a hard time keeping up with everything that is going on. That IntelliSense doesn't pick it up fast enough. So same thing, port. We specify a 255 value, which means no operation on the NRF side of it. So that way it'll just send this full byte, and in return it'll give us the bits of this register whenever we're passing it. And now we specify how many, actually where we want to put it. So it will be on result and how many, and it will be 1. And we reset CSN to high, and we return result. Alright, so now we have a way of reading data using SPI to whatever is connected through this CSN wire. The next one is this one here, which is writing data. It's similar to this one. Actually, I guess this one is telling you that it's already writing data, right? So not difficult to follow. But this is assuming that you're only going to write 1 byte. We have a second one here that is going to do the heavy lifting for us. So this one will just be a pass through to write register, and we'll give it the register, the data, and 1. And then on this one is we're going to do the actual coding. So to write data, you go back to this one. Look at the commands for writing data, and this is the command for writing data right here. So this is both the command and I guess you can call it the bit mask. So this is the actual command, and this is your places where you can put data. So everything that says A, those are the bits that you can change. And if it has this one set at 1, then that tells it that you're going to write it. And if it's 0, then you're going to read it. And these two are ignored. So let's just copy this. And we'll specify, we'll change the register here, right? Because we already have the register. We just have to make sure that it matches this, right? So we'll do this, and that, and register. And all we have to do is flip this to 0 and the rest to 1s. So that's 5 1s, 1, 2, 3, 4, 5. And this one, I just have to remove the A's and set them to 0s, 1, 2, 3, 4, 5. And we're good to go. That way it guarantees that these ones are going to be 0s, this is going to be 1, and then whenever we have it registered, it's only going to occupy those 5 bits. CSN load to tell the device we are communicating. SPI write blocking port and the register. All right. So this is just to start and say we are going to write to this register whatever we have here. So we're setting the device ready to get the real data. We're just telling it what we're going to write it to. So now we can say SPI write blocking. It's the same thing. I specify the port, and now you specify the data. Int AP, and is the data we're bringing in here. That's going to be a bunch of data, right? It's going to be an array, which means this is incorrect. It should be a pointer like that. And let me go back and change it here as well. This, okay. then now that we have that, we specify how big this is going to be. So we use size of data. Actually, no, this will only give you the first bit. This is incorrect. We already have size up here. So we'll use the size that we're telling it we're going to send. Okay, so once we write the data, CSN high, and that's it. We're done with this function. Now that we can read and write, we can configure whatever device is connected to SPI. So just to, every time you trigger configuration, we want to reset our pins again. So we'll say CE low and CSN high, just in case they were in a different state. And then we are going to sleep in microseconds 1500, and that's because that's what the data spec says on the flow. That's the reset. After power up, it's 1.5 milliseconds. Okay, so we also need this somewhere, right? We need to wait 11 milliseconds to do a power cycle, and then from power up, and then we can access the device and wait 1.5 milliseconds. So since we are going to configure this thing, actually it's going to be here, because when we instantiate this thing, we want to delay it. Right, so right here, we'll say sleep in milliseconds. Let's set 11 milliseconds, right, just to give it time to boot up on a power cycle. And here it will be 1.5 milliseconds from configuring it, right? Which means that this is after we set the power up on the configuration register. So let's go look at configuration on the register map. It's address 0, and we said we're going to do bit number 1 and number 3. So we can write a register now, and the register will be 0, 1, 2, 3, 4, 1, 2, 3, 4. So we need bit number 1 and bit number 3, and this will give us our default config. Okay, and we have our delay. Okay, next, we want to specify no acknowledgement. So we're going to disable this because I'm not going to use it for this demo. Yeah, let's just disable it. So set register, write register, register 1, 0. Should be good to go. Disable acknowledgement. Now we need to specify the channel. I'm not specifying everything because we're keeping all the defaults. So here's the channel number 5. It has a range between, so by default this channel number 2, and the range of this I honestly don't know how high it goes, but let's just set it to 60. All right, so 5. So we'll say write register, and it's going to be 5. And actually, we're not going to set it to 50 because we are passing a parameter for that. So here's the channel, and that will specify what that is. Right, no need for comments because this is self-explanatory. The next one is setting the name, and we have the name already, and that would be under let me see. This one right here. So we're changing this one. We're going to specify what the name of the connection is. We only have 5 bytes, so we're going to use all 5 bytes. And it's 80, and also this one. And we're going to set the same whatever we give it here. So again, write register, and we'll say name, and the size will be 5. Actually, it's 0A and 10. Okay, we should be good there. And the last thing we need, it would be this one. How big is our message? So we have we can go from 1 byte to 32 bytes. We're just gonna default it to 32 bytes. Right, register 0x11, 32 bytes, and it is x11, 32 bytes. So that's our configuration. We're good to go. So now that we have a configuration, we should be able to switch modes between TX and NRX by simply flipping one of the bits in the register and setting CE to low or high, whichever we want to do. So let's go to the flow. What are we setting first? Type transmitting. So transmitting is going to be this path right here, which means that this bit number 2 of the bit number 1 of the configuration has to be set to 0, and CE has to be set to 0. So we'll read the register, and this will be 0 for configuration, right? So this is the config, and now we can just say register, and we'll flip the bit. It was bit number 1, so set it to 0, and then set CE low. And how long is the delay? We need 130 microseconds delay. All right, so see, microseconds 130. So that will give us, actually, we still need to write it. Register and the register 0 and the contents of it. So we're reading the register, changing the bit to 0, writing it back, setting CE to low, and then waiting a delay. Same for this one. We need to read the register 0, right, config, and then on this one we're going to set it to 1, bit number 1, right, and then we write, so the rest is identical as what you see on top. So register 0, write the constants of reg, and then CE high. That's what it says right here, right? We're taking this path now. So we're going to change this to 1, and we're going to set CE to high so we can start receiving data. And then we delay it. It's the same delay, 130 microseconds. So there, we're done with that one. Now sending a message. What do we need on this one? Let's see. Commands. So to send a message, we need to load a payload, right? The data that we're going to load. And we do that by sending this command to NRF, to the NRF unit, and then it will know what to do with it, right? So we'll take this, and we'll specify the command, and it'll be that. So B for binary, set CSN low. And by the way, so now I'm here on the send message here. So in order to send the message, obviously we need to have CSN load because we're communicating, right? And then we have to write the command, and then we write the data. You know, we already have this one. Now we're gonna load data into FIFO, and then we're gonna pulse this for a little bit. CE, it says 10 microseconds. However, that's not very reliable. I don't know if my units are, you know, maybe they're fakes, but it seems to need a bigger delay, more like 300 microseconds to be reliable 100% of the time, which is a long delay, and I'm not happy with it, but that's what I have. So I wait to pulse this for a little bit and then send it back to 0 again, and that's about it. Right? And that delay may be due to this one because it needs time to settle again into transmission mode. Doesn't matter. Let's just continue. So CSN low, and then SPI write blocking. We specify the port, we specify the command, and it's going to be 1 byte. And because this is not an array, you have to say this, right? Next, now we can write the actual data. Let me see. SPI write blocking. Specify the port. We're going to specify the data, which is the message. Oof. Message. And we know that we're sending 32 bytes. So obviously, if you change the configuration for this thing to be dynamic, then you have to keep track of that. So when you send messages, you know how big they're going to be, or you're going to have to pass it in a parameter, or you're going to have to calculate it. But you're going to have to keep track of that. So once the message is sent, we're done with just CSN high. Actually, no, that's incorrect. We need to, yeah, CSN high. That means we're done sending data. Now we're going to say CE high, and then we sleep for 300 microseconds. And then we set CE low. So that should be able to send a data packet or a message to any unit with the same channel, same name within range. So now we want to receive a message, right? So if we have a message, we want to be able to get it and put it on a buffer so we can look at it and do whatever we want with it. So same thing as before, we'll set a command. Oh, come on. Command. And the command will be, let's see the commands right here. So this one here for receiving data. Right, this is for transmitting, that's for receiving, and you can see the difference between the two. It's just 1 byte. Actually, this one is 0 and this one is 1. And this one is 0. Anyways, doesn't matter. So once we have this, again, CSN load to initialize communication, SPI write, blocking, and specify the port, the command, CMD, 1. And now that we're sending this command to say, okay, give me the data, now I need to send a read SPI command, so or function call. So port, and then we specify the bit that is going to be sent for every byte. It's going to send it 8 times, so it starts reading the data back, which is a no operation. And if you're wondering where I'm getting this from, it's coming from here, right here, no operation. And this is what it's used for, right? It's not just for reading the status of a register, it's just for reading data. Okay? So the next thing is, we need the buffer to store this. And this is under message. And it's going to be 32 bytes. CSN hi. And we have a message, right? Sending the right command, initializing communication, telling it what we're going to do, reading the data, and we set it to I. Now I don't know why this, oh, I forgot the T. There we go. Are we good? Yeah, here is message. Alright. I don't know why it's not blue, but we'll figure that out. Okay. Next one and last one is this one. To see if we have a new message. So for this one, let's go to register map, and it should be somewhere at the bottom. This one right here. So this is the FIFO status, and to check if we have a new message, or I guess if we have a message pending, not if we have a new message. But if there is something on the queue, we want to grab it, right? So we are going to use this one here, right? Not if it's full, but if it's empty. So if it's empty, obviously we don't have a message, and if it's not empty, we have a message. So that's bit number 0. Right, so this is the bit. It's 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, all the way through 7. So 8 bits. And we want 0. So it's 17. So we'll get the status and save it. Status. And read register. No. Read register. And we said it was hex 17. And now we can just return the bit number 1. So 1, 2, 3, 4, 5, 6, 7. And we do a bitwise operation on status. Status. Now why this? Oh, there we go. Alright, so that's it. This is the entire class. I'm sure we have a lot of errors and typos to correct. We'll get to them when they come up. We have our class definition or header. Right, this is where it starts. We have whatever private variables we need, private functions we need, public functions, and then the constructors and destructors, just the definitions themselves. So that means that we can go to main. Actually, before we go to main, we have to go here and specify that we also have this Nrf24.cpp. So when we come here and we want to include it, we can say Nrf24. We can instantiate it, so Nrf24. Right, we can call it whatever we want. We can say wireless, doesn't really matter. And it's going to take SPI. Is it 0? Let's see. Where do we go? SPI 1. So this is connected to SPI1. I'm connecting to this GP10, 11, and 12, which is part of SPI1. So it will be SPI1. We still need to add one more. Include hardware SPIH. There we go. There, it changed. And now it's asking for CSN and CE. And we said CSN was going to be 9 and then 8 for CE. So this one is 9 and CE is 8. Have it initialized. We're good to go. So now we can say, actually, I don't want this long name. Let's go NRF. So I can say Nrf Config. Tell it ABC is going to be the name. 1, 2, 3, I guess. Actually, 1, 2, that's 5 characters. And we specify channel 60. And then we can set an initial configuration as a receiver or maybe transmitter. And we're good to go. Right? So we're done writing the class. Now we're using the class. And to use the class, I guess here in the loop, let's say you wanted to, so I'm going to go by what I had before on my previous video, which is this unit should be able to send and receive, right? So ideally you want to, actually let's just make it so it can send, right? So we already defined it for sending data, and we're going to have it so it sends data every 1 second. So every 1 second, let's just sleep for 1 second. And once it sleeps 1 second, we can send the data. So we can send, we can say NRF send data or send message, and you specify the data you're going to send. So this is a message. Now, is this 32 bytes? I don't know. It has to be 32 bytes, right? So we have to define a variable for that. So we'll say buffer out, and it'll be 32, and we'll define it to nothing. So I guess we can do it, assign the data here and just say sprintf buffer out, and it will have that, right? Just that, doesn't need the rest. And it will be, actually I don't need any of that, I can just type it here. So this is a message. How big is this one? $18. All right, so we're good. And here, I can just say buffer out. My data goes, and then it's going to wait X 1 second, send the data again, and it's going to keep sending data. Right? If you want to send data both ways, then you know, we'll forget this, and then we'll create another buffer. We'll say buffer n, and this will be 32 as well. And we'll do that. It doesn't really matter if we put the equal sign. Still works. And we can say, so how can we do it without having to send data back and forth? Something to trigger this data without any messages. Let's assume that we have a flag, and this is just going to be an int. I'll call it flag, and we'll set it to 1. So if the flag is 1, we can send messages every 1 second, and if it's not 1, then we'll receive. We'll just wait for messages, right? So whichever unit has a 1, it'll keep sending messages, and the other one will receive. So we'll say if flag equals 1, you want to send a message, and we'll send this message here. Let's add a counter so we know it's a new message. So counter equals 0. And here we'll move it down here, enter, and we'll specify let's say message number, and we'll specify the data that is coming in, and we'll just say here counter plus plus. Actually, let's increment it before that, and we can send the message. Buffer out. We should be good to go. Now we can say if nrf new message equals 1, actually equals true, then we can receive the message. So we can say here nrf receive message buffer in, and I guess if you had something to print it with, you would just say buffer in, and we'll print that message, right? So first we're checking. So this is going to be looping a lot really fast, and actually we should put a delay here once it sends a message. So let's wait 1 second. So if it sends data, if the flag is 1, it'll start sending data. It'll increment the counter, so the message you're going to receive will be message 1, 2, 3, and so on. Send the data, wait 1 second, and then something on outside of this loop, this is going to be always waiting for a message. So every time it loops, it'll check this and say, do I have a new message? If I do, then I should go get that message and then print it. Right, so that should work. So before we do anything, let's compile this thing. Let's get rid of all the errors that are going to come up. And there's quite a few. Right, so starting with this one, that's because I have that right there. Right, so let's go here, right there. Hardware SPI. Let's compile once more. More errors, and now it's complaining about this one here. Well, let's go with this one first. Info. Oh, okay. So it's complaining about this one, and let's go see what the issue is. Okay. All right. So this ended. I don't think it needs anything at the end. We have one more. Now it's complaining about this one. And this is because we're just passing data ABC123 and it's a pointer. So we need this, I believe. Okay. Now it's complaining about this one, and it's complaining because, why is it complaining? Is this escape sequence? Oh, okay. I forgot how to send a message. Actually, I forgot how to set parameters here. Because that's supposed to work. This is supposed to work. So let's do this. So that's that one. Right. Message number. Where's my number? As printf as defined in header stdio. Did you forget to include it? Yes, I did. stdio. Okay, so include stdio. Which means that I didn't need to do all of that stuff that I did. So let's just reset it the way we had it. And let's see what this one's complaining about. Sleep. Microseconds. File. All right, we're getting close. This is a function, by the way, so that's why it's complaining, because I don't have the open and close parentheses at the end. File once more, and give us. All right. So now this one. I believe it's GPIO, not GPI, GPIO. That one. Okay. Oh man, so many errors. Write register, blocking. This one's missing parameters right here. Writing one. And this one is what? So valid commercial and chart tools. Okay, so we'll convert this. All right, now it's going. Looks like it is. They finished. Still going. All right, we have success. Let me just check in. Make sure we're still going. Cool. All right, so now that we debug everything and everything should be working, now we're going to change this code to actually work, and we're going to connect the 2 units, and then we'll connect it to my phone, and then we'll see it working, and we'll see what we can do. So I am going to bring a file in here. So I don't have to rewrite it from scratch. And I am going to bring the, which one is it? I'm going to bring this file in so I can communicate with my HM11. Okay, so I'll bring this in and just put it here. Doesn't matter where it goes. I need UART, so I'm going to add it here. Hardware UART, and then specify my executable, which is hm11.h. You can see this one is a single file. That's because I have my header and my implementation on the same file, so H file works just fine. So this one, to use this one, we are going to go to main, include it, hm11, and I'll set it up here. So this one is connected to the pins down here, which we can't see. So let's go. Let's see where that is. I don't have it open. Let me. Another sheet. So I have my HM11 connected to these 2 pins, 17 and 16, or 16 and 17. And this is part of UART 0. So 16 is TX and 17 is RX. So we can say HM11, and we'll call it phone UART 0. And it's asking for the baud rate. That's going to be 9600 is the default one. And now it's asking for text, which I think it says 16. Yeah, 16 and 17, right? So that's all I need to do. So now I should be able to send data. So I am going to have one unit sending data. So I'm going to compile it once with a flag set as 1, and then the second time on the other unit with a flag set as 0. And this one's going to be sending the data. I'm sorry, the one that doesn't have the HM11 or the phone connected to is the one that's going to be sending data, which will be this. And the other one is going to get data and is going to send it back to my phone. So this will be, let's see, can I send data? I should be able to. Let me see how the function is on this one. For sending data, see if I can send multiple commands. Yes, I can. All right. I was looking for this thing, the ellipsis. Okay, so here I don't need the print because I'm going to send data via serial communication. So phone, send message, and the message we're going to send is going to be just whatever data we got, and then a control return. This is needed for my phone to know that that's the end of the line. And then we'll say buffer input, right? So that's it. I'll be connecting to the phone, sending data, and all of that good stuff. So first I'm going to compile this. Let me look at what I'm looking at. So I'm going to compile this the way it is. The flag, actually not the way it is, like this. The flag is going to be set to 0 because the unit I have connected right now is the, hold on. So the unit I have connected right now is the one that has the HM11. Let me flip this over a little bit. So I have this unit that is going to connect to my phone, and then we'll display. So let's send the data to that one first. Let me compile one last time. Okay, everything went good, 100%. Well, actually, no, this is a problem. So let's see this one here. That should be it, I think. Okay, we're good to go. So now I can go back to my data here, go to YouTube, go to the driver from scratch, built, and this is the one we just created. And just to make sure that is the one we just created, let me compile again, and then we'll go back here and it'll pop up down here when it's done. Oh, it didn't because the code needs to change a little bit. So there's one line. There it is. There's my driver, UF2. The name is coming from this here, from my project, driver. Right, so I have it there. Let me open one more. And I'm gonna reset my Pico so it comes up here. There it is, right here. So let me drop it. Okay, so that's one. The other one is the one we're going to set the flag to 1. So this one says data every minute, which means I am now going to connect my other unit. And let's see. Let me switch views. So this is the one we had connected. I connected this one now, and we are going to now program this one. But I still need to compile the other one with flag 1. So let's do that. Now, doesn't mean that it's going to work right now. We'll see. You never know. Let me bring it over. We're good. Let me switch my view. Let me plug this in. Just get a connection here. It's a little too far. All right, so I have my 2 units. You can see the light blinking there. And let me see if I can flip it around. Do I have a cable, long cable? I don't think I do. Hold on, let me move this. This is just so you can see the light blinking and you can see when it connects. So let me open my phone, and we're going to use this application, and we'll just open a new one here. Go to my settings, HM, that's my connection, dismiss it. Let me bring in a console here, and that's my console. You know, obviously it is connected, right? But somehow it's not communicating. So we have to debug that part to see what the issue is here. But, oh, where'd it go? There's my console. Is it connected? HM. Dismiss. Right? So the first thing we're going to do is we want to make sure that this thing is actually sending data to the phone. So let's disconnect this and reconnect it to this one. Okay. And bring this up. Where's my code? Hold on. There we go. Move it over, just so we can see what I'm doing, right? So I am going to move my phone right here. So when it starts getting data, you'll be able to see it there. Put it right there. The glare. There. Let me change the font on this thing. Where am I? Okay, so the other issue here with my phone is that the application, I haven't done an update for the new iOS. So that might be what's causing it to freeze. Let me connect once again. And dismiss this thing. Bring my console over. Set the lines to a little less so everything gets bigger. Should be able to see it better. There it is. So there's my console, right? Supposedly sending data, but it's really not sending anything. There. Okay. So first thing we're going to do is just send data. So we're just going to loop here, make sure that everything's working correctly. This is just going to be debugging data, and we'll sleep for 1 second. And every 1 second, we'll send data. So phone sent message, and the message will be message 1. So return. Let me compile it. And same thing as before. Compile once again. go back to this file and that one. So there's the message. It is sending data just fine, not an issue. Right, so the next thing to do is to take this, put it here, just in case the data that I'm getting there is corrupted, and I can remove this flag, this, set it to 0, compile it once again. Let me reset my unit. And you can see that we're getting a ton of data, right? I don't know if you can see, but the numbers, you can see the numbers getting higher and higher. So the message is being sent. So the issue that we're having on the other one is that it might be having an issue formatting this thing. So let's see how we can get around that one. So let's create just a temp buffer here. So let's just go temp and make it 100. And we'll define it to nothing. And here we'll just say, we'll say sprintf, and then we'll have a message. So it's going to go under temp and no message, just data. So let's just put data here and that, and we'll say buffer n. Okay. And instead of having this, we are going to send the temp, right? There's something wrong before we go on with this, because this message is supposed to come up every 1 second, not that fast, right? Because according to this, it's once per second, because it'll send the message and then just wait. So, oh no, never mind. I'm saying this incorrectly. Hold on. So this should not be even. This should not be. We should not be getting a message to begin with. Let me put it with the way it was first, so I can explain it. All right. So this is what we had, right? And we're seeing this message scroll through the phone really, really fast. So that should not be happening because we don't have the other unit connected. Right, so we don't have the other unit connected, then we shouldn't be getting a message. And we seem to be getting a message. Now, there may be something else here that the NRF is picking up and it's assuming that it's data. So that may be why the data is incorrect. So what we're going to do is just to play it safe, we are going to go to receive message here. Well, let me first verify. So this is the name, that's the channel, and when we receive a message, actually not that. Just so we only get real data, we are going to check the data to see. Let's say that we want to make sure that buffer n one or 0 is equals, let's put q or a. If it's that, then we can safely say, yeah, we have a message, right? Just in case that channel may be bringing a lot of data and the unit's picking it up. regardless of who's sending it. So let me compile this, and we should not be receiving any data. Let's put a 2 here just to make sure it's new data. Okay. Move this over. And now no more messages, right? You can see that there's nothing there. That's what we want. Only when we get real messages from the unit, which is the other unit. So now this one's there, and I'm gonna have to switch once again once this is done. So I'm gonna connect this, and I am going to connect the other one here. This stuff that you just saw is just the connection of this one because I swapped the cable, okay, to connect this other one. So let me go back to this code here, and oh my goodness, I made a mistake on the other one. I ended up leaving the flag as 1. So let me go back again. I don't have another long USB cable, so I can't plug it into my computer. Alright. And another thing is that because I've been moving this thing, it's likely that that cable, one of the cables here, is not making a good connection. So that may be another issue why maybe we weren't receiving data. Okay. So let me compile this once again. Build it. Now I'll move the data over, or the file over. Okay. I'm not receiving any messages, which is what we want. Let me plug in the other unit and plug this one here. And now I can set it to flag set to 1 so we can send messages every 1 second. And yeah, that looks good. Okay. Make sure everything's connected correctly. And it looks like I might have an error somewhere, likely on the code, because the connection is good. Make this a little bigger. One more thing. Yeah. All right. So those are the messages we have so far, but they're not the ones we're looking for. So let's review the code and see what the issue is here. And so let's see. So first, let's make sure we are initializing this thing correctly. There's my water. Alright, so we have the port CSN CE. We have a million here. Yeah. So we're initializing SPI, second the function for 10, 11, and 12. Initialize CSN CE. Outputs for CSN CE. Low and high. Make sure these ones are correct. CE0, CE1, CE0, CE1. Okay. Reading data. We want result. See. CSN low. The port, the register, 1 byte. Read blocking data. Put it in result. And 1. CSN high to result. We're good. Write register. Right. 3 zeros. 3, 4, and 4. Register. CSN low, blocking, register, we're writing, we're reading, we're good. Data size 32 bytes, set it to high. We have the right configuration. We're setting, yep, 1500. Disable everything for auto acknowledgement. So the channel 60, name 5, 2, setting the mode TX, reading the register, flipping bit number 1, writing the register back, setting CSN to low, and waiting. It's good to go. Reading the register, assigning the bit to 1, writing it back, CSN high, CE high, and then wait. Sending data. Okay, we have the command. We are writing data to the port, the command. And 1 byte. Then we write the entire message, which is 32 bytes. CSN high, CE high. Yep. Data. 1, 2, 3, 4. Writing, reading, putting it in the message. Port the command, port, no operation, message, 32 bytes, CE high, and then receiving data. Something's not adding up, hold on. Okay, so this is incorrect. So we're supposed to have 4 and 4. So this one has 3 and 1, 2, 3, 4. So we're missing 1 0 here. Is this correct? Yeah. Alright, so this tag was incorrect. for reading when something was available. So let's see what we were getting first. We were reading this one when FIFO was full, so that means that we were probably receiving data. Maybe. Let me make sure that all of these ones are 4 bytes. I mean 8 bytes. Yeah, it is 8 bytes. It is 8 bytes. Okay, take a second look at config. Yeah. All right. So let's try again. I'm gonna compile this one, and then we'll go to the data itself, to the one receiving the data to send it to my phone. So there it compiled, and I'm gonna drop it in. Now I'm gonna change the flag to 0 so we can see data here. And we don't need this anymore. We shouldn't. We'll see. Let's just leave it like that. Compile again. Alrighty. Let me see. Oh man. I am stumped right now. Hold on. Okay, so let me see. We are going to compare this against previous code to see what the issue is. The issue may be just here, or maybe the way this is being set. So what I'm going to do is I'm just gonna ignore this, and I'm gonna set it hard-code it into the class itself, so we can make sure that this is correct, right? So that's the first thing we want to do. So let's look at config, and we're gonna overrule the channel. I'm just gonna put 60, and I'm gonna make sure this is correct. So that's whatever that number means. But we are going to specify here the name. So it'll be just name 1. So that's 5 characters. Right, and the rest should be identical. Oh, which one? Oh, yeah, you're right. This is a B. Yeah, that would create an issue on that one. Okay, so let me compile. I guess, you know what, before I compile, let me put it back the way it was, because I don't want to switch the other unit, and then we'll come back and reset this. So let me put it that way, and then we'll go here, have this there, 1, 2, 3, 4, 1, 2, 3, 4, we're good to go. Okay, hit compile. Alright, so that compiled, we're still not receiving any data. And I don't know if it's because maybe my units, my breadboard is not correct. But, so this is fixed. Let me search for this to see if there's anything without a B. Yeah, this one too. So that's an issue. right? It should be 1, 2, 3, 4, and then 4. 1, 2, 3, 4, and then 4. Let me do an additional search to see if there's anything without a B. Alright, that looks better. Let me compile once again. By the way, thank you for pointing that out, because I was overlooking that part. Alright, so let me switch my view again. Okay, so I'm gonna disconnect this. I'm gonna connect this one here. And I will change the flag to 1. Still no luck. Why not? Why is it so difficult? 1, 2, 3, 4, 5. Let's see. Where's my config? Right here. If this doesn't work, the next option is that we're just gonna debug it on this one, because what we're gonna do is we're gonna start reading the registers of this unit and sending them back to the phone to see if they're changing. Because I'm sure something there is overriding that part. I just don't know what that is. You know, I would think it would be this one, but I'm reading it, right? So that shouldn't be the issue there. Okay, so let's do this again. Let me compile. Okay. And let me switch my units again. Okay. Let me change this to 0. All right, so that didn't work. So let's do this. Let's debug it. First thing we want to do is we wanna read the configuration to see what we have. Right. So we're just gonna put a loop here, and we have configuration. Right. We have the config, and we're setting it for transmitting. Actually, that's the issue. We don't have to do anything. So the issue here is that when we're receiving data, this part, we're not switching the mode, right? So that's an issue. So this should work. We just need to set it here and say NRF mode receiving, get data, and then NRF mode transmitting. So it just keeps looping. So, you know, I'm sure that's what the problem is, but we're about to find out. You know, we wouldn't be able to send it because we're not configured to send. I mean, no, we're not configured to receive. Or not. Let's debug it. Make this smaller. Okay, so debugging. Let's do the loop, and we'll sleep for 1 second, and we'll read. So let's just do a read, and it will be 0, and we'll read that the configuration first. So we'll say NRF read register, and we'll say 0, and we'll put it in red. Then we can print on which buffer. I kind of have created a buffer of about 100 characters. It's called temp. I guess it's not there anymore. All right, so we're just create a buffer, and we'll call it temp. Let's go 100, and we'll do sprintf. We'll put it in temp. What is it? 8. That was done? I think it is. Is that correct? I don't remember this how you display hex values. We're about to find out. All right, let's compile. There's no data. Oh, I'm sending it. Sorry. I got data. I'm just not sending it. So phone send message, and it will be the temp. All right. So let's compile once more. All right, so there's our data. Obviously, that's not the way you display hex values because you can see that it's not displaying the right data. So let's Google it. I know I have it somewhere in there in code, but I just don't remember where. Hold on. So let's bring this over, and let's do sprintf x, or yeah. Yeah, that's the way I have it. Well, it's lowercase. I don't know if it has to be uppercase. Maybe I just needed to put a 2 instead of the 8. So let's do that. Let's compile once more. And move it over. Alright, that's still not hex though. That's I had it correct. It's just this part. There's something incorrect here. Okay, just like that, huh? Let's try that. No, something's not right here. Oh, I'm sorry. I'm trying to print binary, not hex. Binary. Jesus, I had it right. Um, okay, so it is like this. I think 0, 8. I'm sure it's like that. All right, now we're talking. All right, so this is what I wanted to see. So you can see that I'm printing binary, right? So I want to make sure that is my configuration, and you can see that it is bits 1 and 3, the ones that are set to 1, which is what I'm saying in the configuration to do that, right? So that's one of them. So that would be for what? Let's look at this code here. Go to flow, and that means that I'm set as receiving if it's set to 1. And that is because I have the flag as 0. Well, let me remove the power of the unit so everything can reset, put it back on, and see what we get. All right. Still receiving. I'm sorry, it's set as is being set as a receiver, which means that the other unit is incorrect as well, because it should be as transmitting, because that's what we're saying here, transmitting, right? And we're not changing it anywhere, because this thing is not being set anywhere, right? We don't have we don't have this. This is not being called yet because it's stuck in this loop. So let's go look at the configuration, because supposedly we're setting not the configuration but this mode here, and see what this one's doing. So this part is not taking place for some reason. So we are going to cancel that part, run it again. Yeah, I kept looking for the 0 once and I kept asking for hex, so yeah, that wouldn't work. Let me move this over. And the configuration is still incorrect, so let's go back to this one and see what we're setting. So the default configuration here, obviously we are setting it to let me go back and understand it correctly. So power up. All right, so here's another error. I was supposed to be setting power up, not primary receiver. So here in this part, it's supposed to be power up. This sucker is incorrect. So if we go to register map, power up is that one, right? So when we're switching mode, we're supposed to be changing this one, not power up. So let me take a step back. This is correct. These ones are incorrect. These ones should be, that is correct, 0. Is it correct? Yeah, I'm changing bit 0 to 0, and I'm changing it to 1. Okay, so let's change the mode here before we get into it and say nrf mode rx compile once again. Let's see what you have. Not for debugging it. I don't have to change the flag because we're debugging it here, and the flag we're using it down here. So we're not even here. We're not even close to this. I'm trying to make sure that as I change the flags, as I change the configuration, the register is picking up that configuration. So let's do this. Let's drop it in again. So now you can see that the we have 1011, right? So that's receiving mode. So that one works. It's fine. And since it works, if I right after this, if I change it to NRF transmitting, we should get one flag of receiving and one of transmitting, and then everything will be transmitting. So let's see what we get. Just one more debugging step to do. I'm sure it's something simple. I'm just not seeing it. All right, so you can see here that it went back to transmitting data. All right, we're good. Let me make this slightly bigger, just a little bit bigger. Yeah. Okay, so the next thing we want to see is what we have for channels. We want to see what we have for, yeah, let's check the channel to see we have channel 60. All right, so we know this works, we know that works. We know reading and writing registers works because we've been changing those. So all right, so that's our channel. Is that 60? Let's see what that is. Let's see, programmer, decimal, 60, 2 zeros and 2 zeros and the rest at once. Yep, that is our 60. Okay, so what are we missing here? When we send the data, go to definition, yeah, CSN low, blocking the port, the register, or the command, and then the port, the message, 32 bytes, CSN goes to high, CE goes to high, sleep 300, CE low. Receiving CE is high, transmitting CE is low. Okay. Let's look at this one. And see what we have. So we are getting 1 and 2, 3, 4. So we're getting this one, which means it's full. And we're getting this one, which is we're not sending data, so this one is empty, so that's fine. But same with full. So we have messages. So since we have messages, that means that we should be able to get those messages then, right? So just to make sure that my data is correct, when I check my messages, nrf new message equals true, then I'll send my data, and this is a function. Is that what I have here as well? Yeah. All right, that works. So now we can get that message and see if there's another issue here. So where is it? Right here. So what we are going to do here is we'll have that message. We'll also have the data we're getting, and we'll get buffer in as well, and we'll see what comes out. So if we have a new message, then we'll say nrf receive message, and this will be the buffer in. Is that correct? And we'll see if we get that data. Okay. All right, so there's the data. I mean, obviously it's been sending data, it's been working, so I guess we have something incorrect down here. All right, so there has to be something funky down here. All right, so let me say something here. So this line doesn't belong there either, because that line is for sending data as NRF, and we're using the phone. Just confusion. That's useless. All right. So here's the data that works, right? Which means that if the flag is 1, it'll do this. And otherwise, it always checks to see if we have a new message. And if we do, it goes and receives the message, and then it'll send the message. Obviously, we never got to test this part. There was something funky about this one. So what I'm going to do is, without changing anything, I'm going to let it fall through here with this flag set to, oh, take that back. It is needed because we need to receive data, right? So then the issue is here. It's actually not that. So the issue is this. Let me comment this out. The unit has to always be set as receiving. Okay, that's number 1. And when it falls here, because we are going to send data, NRF mode transmitting, then we switch it, we send the data, and you know, I guess I'll leave the sleep there. And then NRF has to switch modes to receiving, and that guarantees that this will always execute, because then we don't have to change it here, because if it falls under new message, that means that we can receive data, right? But just to play it safe, we're just gonna leave it like that, just in case it gets flipped over. Have duplex? No. Well, actually, I don't know. I haven't looked into it. So let's test it, right? We're gonna log it in the 2 units. Now it should work. And actually, I'm gonna move this line, this one, down here. So instead of sending this message, we actually get the counter. Actually, this one should work. So that should work. right? It's we should be able to pick up the data because we are getting the data in. Yep, that is true. That's why I like C++. And you can put very meaningful names that just flow. They're intuitive, so you don't have to write comments all over the place. And they're encapsulated within their own object, so you don't have any issues of overriding a variable somewhere that might be global and might be critical as well. All right, so there we have it. We should be able to send this data. This should work now because we will get the message. And there's no counter here. Where's the one where we were counting something? Oh, this is the one that I sent the data for the counter. Never mind. Okay, so we're getting the data. We'll send it. We'll have this commenting out. We're going to compile it. The flag is set to 0. Right? So just to recap, we're setting it as receiving, and it will always be receiving if the flag is set to 1. And on every loop, it's going to come here, change it to transmitting, send my data, and send it back to receiving as a default, and then wait. For the other unit, because the flag is going to be set as 0, it's never going to go into here, and it's always going to go here. And because it's already receiving, it will always receive data, right? And just in case it's not, if it falls in there and something flips it, it will flip it back over. But however, that means that we will have a message, which means that we are receiving. Let me remove this part. Okay, I'm going to leave this debugging data there just so we can have it just in case we need it. Nothing's guaranteed. There's always small things that your code compiles, but it might not work. So let's build it. Set to 0. Let's see. Yeah, flag is set to 0. Hold on. All right, so let me load it. All right, so you can see now we are receiving the right message, right? Because now it's set to whatever it is. So that means that the other unit is working correctly, but the code is not correct. It is correctly because it was by default as transmitting, and it's always looping within that same block of code. So it goes in, but if something goes and flips it over, now it won't transmit because it's not being set. So if I configure this code and the flag is set to 1, and just so we know this is the one that's getting, we'll put new message. Right, so let me disconnect this unit, plug it into this other cable. So that's the one. It's no longer connected to the computer, but you can see blue light connected to my phone. And now we're just going to program this one, and we should get new message instead of message. Right? So let me program it. Dump it. And we should get new message every 1 second. Or not. You broke this thing now. What do we do? So what happened? It could be that this one doesn't have enough delay to switch. Oh, actually, it will be this one. That we're switching right back too quickly, I think. message still? No message. Let's see. Oh, God damn it. I didn't set the flag to 1. That's no bueno. So I had the flag to 0, so that's why it wasn't working. I'm guessing that's why it wasn't working. And we should get new message. There we go. So we have new message and the counter is starting from 1 and it's just moving 1 at a time, once a second. And there it goes. So now, if you wanted to use this, obviously you would have to bring in these 2 files, this one and this one, into your projects. And then, oh, sorry, you're not seeing what I'm talking about. So if you wanted to use this, this driver, then that means you would have to have these 2 files available to you, right? You bring them over to your project. You specify the executable. In this instance, for HM, because it's a self-contained file, I have to include the header file. And for NRF, because I have the header separate, I only need the executable code, which is that one. And in my main loop, or my main folder, I need to have access to the header file. And I don't have to be concerned about the executing code itself. And you can use it. So how do you use it? Well, you saw me bring this in, HM11, right? I just dropped the file here. And this one is the same as the other one. It has a class. It has private and public stuff. And it has all the functions needed to communicate. This one communicates via serial communication. And now you just reuse it, right? So that's how you use it. You specify the line, same as NRF. That's your constructor. And then you call member functions to do whatever you need to do. And then you keep using member functions. So, you know, it works out pretty well because you're talking to the NRF, right? Sending a message via NRF. And then you're talking via your phone, sending a message via serial communication. So, not much difference. But if this was a C piece of software, we will have to create structures and variables. A lot of them were going to be global. Accessing them is not the same. You have to be concerned, or you have to be mindful of the naming convention that you're going to use, because you have to identify what's a global variable, what's a private variable, what belongs to what structure, so you know how to use it. This way, you don't have to. Everything belongs to the class, and everything's internal to the class. So the class knows everything inside of it to make it work. Does it make sense?